Hello and very good afternoon to all of you. Welcome to today's virtual coaching class, and we are taking up a very interesting chapter today, that is matrices. Of course, we call it matrix, but then the plural is known as matrices. Hope you're all fine, and I'm sure that we will have a very interactive class with a good participation from your side. Now, before going into the session and starting the discussion on matrices, we had some queries. Many of you were asking queries regarding questions regarding use of calculator. Now, once again, I'm repeating, friends, that calculator can be used, but it has to be a specific calculator. And as per the rules of the exams, so any calculator, any make up to 12 digits and 6. So please remember 12 digits, 6 functions, and 2 memories can be used. Second is, some of you were asking about how you will be getting to the YouTube channel is ICAI CA Tube. So please go through this particular channel and you will be getting all the recorded classes of all the subjects, all your 4 papers. So ICAI CA Tube, please remember this. The third is, the point is from my side, in fact, I request you to go through the monthly students journal, and you can download it from the website icai.org. Just download the students newsletter or the students journal, because every month you will be getting important discussion on any paper, any one of the papers of CA Foundation. And you will also find, especially for business mathematics, statistics, and logical reasoning, various chapters with additional question bank are included in many of the issues. If you look at the last 1 year issues, and you can get the archive, you can get the back issues of that journal as well. So I will request you to please go through the CA Students Journal every month. Friends, a good news is that the Institute has already brought out the model test paper 2020 October version. So what I propose to do is, after completing few chapters, we shall go through the questions which have come in the MTP October 2020. I already have got the questions with me, which have come in the model test paper October 2020 for the chapter equations, which we have already covered, right? So we have covered linear equations, quadratic equations, problems on that, story sums, and we have also done cubic equations. So number of questions have come from this particular chapter in the model test paper, and we shall be dealing with those questions once we get some time after covering few chapters more. So I will request you to please download that particular question paper, and the answers are also given, so that once we take up the questions for discussion here in the BCC, you will be able to follow the questions. And there were some of you who were requesting for some extra sessions so that we can take up personal questions, individual questions. Well, as of now, we have a very tight schedule. You know that every day we have to cover one particular important chapter. So if later on we get some extra time, or if extra sessions are available, then we may take up some of the individual queries. Today, of course, we are taking up matrix, and we shall be covering the entire journey, right from the beginning to the end. So it will include the concept of matrix, the types of matrices, what is a row matrix, what is a column matrix, the addition, subtraction, scalar multiplication and multiplication of matrices. And then we shall go into a very important part, and that is determinants, how to find the determinant of a matrix. And that will lead us to the most important portion of matrix, and that is Kramer's rule, Kramer, Kramer's rule. And you will find, dear friends, that Kramer's rule is used in a very convenient manner for solving simultaneous linear equations, and we shall learn how to use Kramer's rule in solving equations with 2 unknowns, x and y, and then 3 unknowns, x, y, and z. We shall thereafter, if time permits today or possibly in the next session, we shall take up the concept of cofactor of a matrix, From there, we will learn how to frame the adjoint of a matrix, and the last part is inverse of a matrix, right? So we shall see each of them step by step, and I will request you to keep your pen and paper handy, ready with you, so that as we discuss, we can note down the important points. Friends, this chapter is a chapter where you have to learn many new terms and concepts, right? So this is an important part of your curriculum, and number of questions from matrix come in the exam. So you can expect 2 to 3 questions at least, and it can be theory questions. I was just going through the model test paper 2020 October, just now before starting the session, just to have a look at the type of questions. Now in that question paper, I found even theory questions on matrix chapter coming in the MTP. So we shall also discuss each and every theory part before going into the practical applications and before solving the problems, right? So I will request all of you to pay attention and please go through step by step the way in which I will be explaining this chapter. Now, what is matrix? Matrix, you see, is a specific branch of algebra, and it is nothing but a matrix is nothing but a rectangular array of numbers. I will write the word array. So if I write certain numbers, say 5, 1, 3, 2, 4, 6, 9, 0, 7. So you see, this is an array of numbers. What do you mean by array? Array means an arrangement of numbers. Or I can use the word, maybe I can call it, a table. Yes, it's a table of numbers, right? So the quantities which are there in the matrix, you see here we are having 3. How many rows do you see? 5, 1, 3 is the first row, 2, 4, 6 is the second row, and then we have 9, 0, 7, which is the third row, right? So I can write, we have a matrix called A, which is having 3 rows. Okay, so I'm writing rows R is 3, right? You're following? 3 rows. How many columns do we have? So you see the first column is 5, 2, 9. Then we have 1, 4, 0, second column. And the third column is 3, 6, 7. So I can write column is also equal to 3. Okay, so this matrix which you see here, A, is given by 5, 1, 3, 2, 4, 6, 9, 0, 7. It is having 3 rows and it has 3 columns. So we can call it a 3 into 3 matrix, or we can call it a 3 by 3 matrix, which means it has got 3 rows and 3 columns. Okay, so each of the element which you see here, basically each of the numbers which you see here, like 5 or 4 or 9 or 0, each of these numbers are known as elements. So please keep a note of this point. Okay, so in this small example, I have taken a small matrix. It is having 3 columns and it is having 3 rows. So normally we write the rows first, number of rows, and then we write the number of columns. We call it a 3 into 3 matrix or a 3 by 3 matrix. Why? Because we have 3 rows and 3 columns. And a matrix is nothing but a table of numbers. I can call it a table or an array of numbers. It's an arrangement of numbers. Okay, I'm just putting some numbers here. Okay, so you see, we will later on discuss what are the benefits of learning matrix. You may ask at the very moment that, so why are we learning this? Why is it included in the exam? Why is it important for us to study this chapter? Well, friends, just to give you an answer in brief, this chapter matrix is critically important, especially for financial management. Now, as a chartered accountant, you shall all be working in the area of financial management, analysis of risk and return of different type of financial instrument like shares, bonds, preference shares, equity shares, debentures. So for example, when we try to write the risk and return from a particular type of investment, we always write in the matrix form. Okay, so matrix has its application in economics, in financial management, in corporate finance, and in investment management. Okay, so this is why we are learning matrix, and it is an important part of our syllabus. So I can say that a matrix is a rectangular array of numbers, and it can have certain number of rows and certain number of columns. Normally, you see this number which you see here, we normally write. Let us see how we write a matrix. So I'll write it here. Here you see the elements 5, 2, 9, 1, 4, 0, 3, 6, 7. They are the individual elements of the matrix A. Okay. Now let us see, we will write the numbers in terms of letters. Okay, in terms of letters. So I will write A12, A13, A11. I'll start from there. 1, 1, 1, 2, and 1, 3. So I will write A11, the first item in the first row, then A12 and A13. Then the next I will write A21, A22, and A23. And in the third row, I will start with A31, A32, and A33. So this is how we write the matrix, and this is, you see, the notation or the rule for writing matrix. See, every mathematical technique has certain rules. Okay, like, you know, for equations there are certain rules we have done. For identity, we have a way of writing identity 3 dash. Similarly, for matrix, we have certain rules. Okay, and the rule is the convention, right? Or the rule is to write it in this way: 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Which means that every number which you see here, every number, I can write it in this way. The first number is I and the second number is J. It's like this, where I denotes, what does I denote? I denotes the row number and J denotes the column number. Please write down these points with me so that you are absolutely clear about the construction of a matrix. You should have complete understanding of the basics of matrix so that it is important and you can follow. Okay. So, yes. Okay. So if you see, okay, let me take some questions, right? Yeah, Pooja has asked, is AQB important? Additional question bank is important. And yeah, the notes for matrices already has been mailed. Kamal Jain from Thane. The notes for matrices already has been mailed today, so I'm sure you will get it later today. Then Pooja has asked one more question: when will our class get completed? I think, you see, March we shall be having the logical reasoning, and we shall also have the statistics portion in March, and I think you will get the date till when the classes will continue. And then we have a question from Niharika from Andhra Pradesh. How many questions can we expect from equations chapter? Well, it can be at least 4 to 5 questions we can expect, right? Okay, so now let us carry on and see. You see that every letter, every element in the matrix can be written in this way: Aij, where I is the row. You see, A21 means 2 is the row, it is in the second row, but it is in the first column. Please see, A21. Okay, you take any random element. Let us take A32. So A3, this 3 means it is in the third row, and 2 means it is in the second column, right? So you can see the first number Aij, the first one denotes the row number and the second one denotes the column number, right? And you can understand as we move from the left hand side to the right hand side, what do we see? What do we see? We see that as we move to this side, we see that this J, the column number changes. Row is same, but the column number will change. Okay, the column number changes as we move from the left to the right. So you can get a question that as we move from the left hand side to the right hand side of a matrix, which one will change? It will be the column. The row will remain the same, the column will change. Similarly, if we move from the top to the bottom, okay, if we start from the top and slowly come down to the bottom, what do we see? A11, A21, A31. Here, the row remains the same, the column remains the same, but the row changes. So as we move to this side, what is happening? The second number changes. The second number means column. So I will write the column changes. And when we move from the top to the bottom, the first number changes because you see here it is 1, 1, here it is 2, 1, here it is 3, 1, which means as we move downwards, the first number changes. In other words, the row changes. Okay, so this is how we create a matrix. And in this example, since we have 3 columns and 3 rows, right? So number of rows is 3, number of columns is also 3. So we call it a 3 into 3 matrix. And a matrix is nothing but a rectangular arrangement or a table of numbers. But please remember that these numbers are random numbers. They don't have any relation, apparent relation with each other. Okay, so this is how we write matrix. Now, the singular, when we talk about matrix, one matrix, it is matrix, but the plural of matrix is matrices. So if somebody asks you what is the order of the matrix, the order of the matrix means how many rows and how many columns are there. So it will be 3 into 3 or 3 by 3 matrix. I will write one more matrix here. Say B is equal to, I'm writing a matrix, let it be 3, -1, 7, 4, 1, 6, 8, 2, -4, and one more, I will add one more row. So let it be -5, 0, and 11. So please see this matrix. Focus on this matrix. Matrix B. So we have 3, -1, 7, 4, 1, 6, 8, 2, -4, and we have -5, 0, 11. Now, what is the order of the matrix? Let's see who can answer first. What will be the order of this matrix? Okay. Now, you see, Ritik was asking, for example, how many questions expected from matrix? Definitely, one question will come on Kramer's rule, one question will come on adjoint, and you can get at least one more question maybe on the inverse of a matrix, or it can be an equation, right? It can be, say, for example, based on addition or subtraction. So I will say at least 3, 4 questions can be expected. Okay. So now, what is the order of the matrix? 3, -1, 7. So you have 1 row, 2 rows, 3 rows, and 4 rows. So number of rows in this matrix R is equal to 4. But the number of columns, if you see, is 3. Okay, so columns is 3. So we will write this matrix is 4 by 3 matrix or 4 into 3 matrix. Okay, some people have got it correct, like Ananya has given the right answer. So the order of the matrix is, we are having 4 rows. So we will take 4. Okay, 4 by 3. So number of rows we are having 4 and the number of columns we are having is 3. So it is a 4 by 3 matrix. Fine. Now let us see the next part. So we have looked at what is matrix. It is a rectangular array of numbers, and the numbers are written in this particular manner so that you have rows and you have columns. Now, the order of a matrix, the order, right? What is the order of the matrix? The order of the matrix is given by 3 columns, and like we had 3 rows and 3 columns, the order will be 3 into 3. If it is 4 rows and 3 columns, the order will be 4 into 3. Okay, and we have also seen that the way in which we notify, we write the matrix is like this: 1 1 1 2 1 3. That means it is AIJ. The general term is AIJ, where the first letter I indicates the row number, and the second letter J, this will indicate the column number. Okay, so please remember this point. So let us do a quick recap. Matrix is an arrangement of elements. Each of these numbers is called an element of the matrix. It is a rectangular array of numbers. The word array, ARRAY, array means arrangement. It means a table, a tabular form. And we have seen that the order of a matrix means the number of rows and the number of columns. Okay, so I hope it is clear to you so far. Now we move on to the concept of equal matrix. Okay, let's see what is meant by equal matrix. Okay, so I will just keep this, but I will rub this side and try to explain what is meant by equal matrix. So a matrix is an array of numbers. It is a rectangular array of numbers, and it has certain number of rows and certain number of columns, and the order of a matrix is given by the number of rows and the number of columns. Fine. Now, two matrices will be equal. So we are looking at what is an equal matrix, right? So what is an equal matrix? Equal matrix means that they have to satisfy two conditions. So two matrix A and B will be equal when they satisfy two conditions. First condition is that the order must be the same. So if A is having 3 into 3, if the order is 3 by 3, B must also be 3 by 3. Okay, first condition. And the second condition is, what is the second condition? The corresponding elements in the first matrix should be identical to the elements in the second matrix. So corresponding elements in both the matrices are equal. Once you satisfy this condition, the two matrices will be equal matrices. So once again, it has to satisfy two conditions. Matrix A will be equal to matrix B only when you satisfy two conditions. First condition is that they must have the same order. That is, the order will be if if A is a 2 by 2 matrix and B is 3 by 3 matrix. Are they equal? No. If A has 3 rows and 4 columns, that is, it's a 3 by 4 matrix, and B has 4 rows and 3 columns. So B is a 4 by 3 matrix. Are they equal? No, they are not equal. Okay, so they must satisfy the first condition, which means that they must have the same order. And order means, order is what? Order means the number of rows and the number of columns. And the second condition is that the corresponding elements must be equal. So when you satisfy both these conditions, we will say that the two matrices are equal matrix. So friends, we have seen so far the concept of a matrix. We have seen that matrix is composed of different numbers, different elements. A matrix has certain number of rows and certain number of columns. The order of a matrix means the number of rows and the number of columns. And every element of the matrix can be written in the form Aij, where the first digit, the first element or the first letter signifies the row number and the second letter signifies the column number. Okay, now we are ready to move into the next interesting concept, and that is transpose of a matrix. So we have done equal matrix. Now we will discuss about what is transpose of a matrix. Very interesting, transpose. So let me write a matrix A equal to 5 minus 1, 7, 6 minus 4 minus 3, 4, 0, and 9. This is my matrix. Okay, right? So we have to find the transpose. Transpose, okay, transpose. The word transpose, I think many of you know, transpose means interchanging the different elements of the matrix. That means the elements in the row will come down to the column and the elements in the column will go up to the rows. So let us try to create the matrix, the transpose of the matrix. Now, the transpose of a matrix is shown by A transpose, AT. So please see the way we write transpose, AT. Okay. Now we will create the transpose of the matrix A. Let us do it together. 5 will remain as it is, no change in 5. But now you see, very interesting. It's like a small game we are doing post lunch. Minus 1 will come down here. So minus 1. 7 will come down here. 7. 6, which you see here in the first column, will go up. So 6 will come up. 4, which you see here, the last row, column 1, 4 will go up here. Minus 4, it will not move. It will remain as it is. Minus 3, which you see here, will come down. 0, which you see here, will go up. And 9 will remain as it is, no change. So 9 like this. This is the transpose matrix. So it's like a small game we are playing together. 5, 6, 4, minus 1, minus 4, 0, 7, minus 3, 9. This is known as the transpose of the matrix A. Okay, I hope it is clear. Now, friends, if you see an important point, transpose, if you see a very interesting point, the point is that, okay, Arun, yeah, equal matrices, we will see more examples. Pooja and Ritik and Arun, we will see more examples of equal matrix. As I said, two matrices will be equal when the corresponding element is same. They are of the same order and the corresponding element. So if we have another matrix here, it must also have this same element in the same sequence. Okay, so we will see more examples. Don't worry. Okay, now let us focus on this. So I think you are clear with the transpose. Now, if you see, we have interchanged many of the numbers. But there are three numbers which has not been interchanged. And that is 5, minus 1, minus 4 and 9. If you see here also you have 5, minus 4 and 9. I am using red color to show it. Please see. All the other numbers have been interchanged, excepting these three numbers. Okay, so please remember, this is what a diagonal. Like if this is a rectangle, you know, the straight line joining the opposite 2 points is called a diagonal. So this diagonal, which goes from the left-hand side and comes down to the right-hand side. So left-hand side, upper left-hand side. So if I face, right, if I face the whiteboard, it starts from the left-hand side, top portion, and comes down to the right-hand side, lower portion. This left to right, and up to down, left up to right down, left up to right down. This diagonal, please note, my dear friends, this is known as principal diagonal. Principal. principal diagonal. Friends, as I told you, there are many terms which you need to learn in matrix chapter. The chapter is not that difficult, but you have to learn number of terms and concepts. Okay, so this is called the principal diagonal. So till now we have seen what is matrix. Okay, we have seen the order of the matrix. I have discussed about what is equal matrix. We have discussed about what is element of a matrix. Each of the number is an element. So both the original matrix and its transpose, they are both of them, they are 3 by 3 matrix. Why? Because they have 3 rows and they have 3 columns. Okay, so they are 3 by 3 matrices. And this is the concept of transpose of a matrix, where we interchange all the numbers excepting 3 numbers. Of course, in case of a 3 by 3 matrix, it is 3 numbers which are on the diagonal. If the numbers are on the diagonal, and this is the principal diagonal, the numbers will not change. Okay, now we look at the next concept, which is row matrix and column matrix. So we have done the transpose of a matrix. We will do some numericals. After this, we will see the concept of equal matrix. I will take some exam questions. First, let us understand each of the topic, each of the terms. Now we see what is a row matrix. So I'm writing row matrix. Now, what is a row matrix? Row matrix means a matrix which only has one row. So if I write like this, say P is given by, say P is given by 7, 6, 2. So you see it has only one row. Okay, it is a row matrix. So it's a row matrix, or sometimes called a row vector. Okay, row matrix, or sometimes called a row vector. Now we look at a column matrix. So this is row matrix. Now we look at column. What is a column matrix? Now, friends, you are all intelligent. You can easily understand that if row matrix means a matrix with one row, then column matrix will be a matrix with how many columns? With one column. Yes, you got it correct. So column matrix. So let me take another example. Let me take a matrix Q. Okay, Q. So Q is equal to -1, 7, 9. So what we are getting is one column. So this is a column matrix. Okay, so this is called row matrix, which has only one row, and a column matrix, I have taken an example, which has only one column, right? So we are discussing the types of matrix, row matrix, column matrix, and the last one is what is called zero matrix, zero. We will take the third one, zero matrix. What do you mean by zero matrix? Okay. So you see this chapter is very interesting, especially, but one request is that when you deal with matrices and when you do the numericals, be absolutely calm, cool-minded, because even a small change in the number, especially when you are calculating the transpose of a matrix, or when you are calculating the adjoint matrix, there will be lot of important points on the sign, minus to plus, number one. And number two, you should be very careful when you are interchanging the number, like you saw the transpose. The number at the top comes down, the number below goes up. So while doing it, you must be very calm, composed, and please do not hurry. You have to be fast, but do not hurry. In other words, you should be accurate, right? So now we go to the third type, and that is called a zero matrix. This is easy. I'm sure all of you can understand now. A matrix whose every element is zero is called a zero matrix. So if I take a 2 by 2 matrix, 2 by 2 matrix, so the zero matrix 0, 0, 0, 0. This is a 2 by 2 matrix, but a zero matrix. If I take like this, 0, 0, 0, 0, 0, 0, 0, 0, 0, 3 by 3, this is 2 by 2, this is 3 by 3 matrix, but they are zero matrix. Similarly, we can have another type of matrix, 0, 0, 0, 0, 0, 0. How many rows do you have here, my dear friends? It is a what is the order of the matrix? 2 rows, 3 columns. So it is a 2 by 3. 2 by 3 matrix, but they are all examples of zero matrix. Okay, so we have seen what is the concept of matrix. We looked at what do you mean by element of a matrix. Then we have discussed about how to find out, how to deal with different types of matrices like row matrix, column matrix, zero matrix, and we have seen equal matrix. Plus, we have learned how to find the transpose of a matrix where we interchange the numbers. And then we have noted an important concept which is called the principal diagonal of a particular matrix. Right. Now we go to the next type, and that is square matrix and rectangular matrix. We can just learn it from here. Okay. 2 by 2 means what? 2 rows and 2 columns. So it is the number of rows is equal to number of columns. So I can write m is equal to n, where m is the number of rows and n is the number of columns. Both are same. Here, the number of rows is 3 and the number of columns is also 3. So here also m is equal to n. But in this case, the number of rows is 2, but the number of columns is 3. So m is not equal to n. Please see. Now, what is a square matrix? A square matrix is a matrix where m has to be equal to n. Okay, then it's called a square. In case of a square, there is nothing called length or breadth. Every side is same. Every side is equal. But in case of a rectangle, the length, we have two parameters, length and breadth. The length is not equal to the breadth. But in case of a square, each side is having the same the same length, you can call it, the same measurement, right? So here m equal to n, here also m equal to n, but here m is not equal to n. So square matrix you can write like this. A square matrix can be 2 by 2, it can be 3 by 3, it can be 4 by 4. Now rectangular matrix will be like this. This is a rectangular matrix where m is not equal to n. So I will write rectangular matrix will be like this, 3 by 2. Okay, it can be 2 by 4. It can be 4 into 3. So these are examples of rectangular matrix where the number of rows is not equal to the number of columns. Okay, I hope you're following and finding it interesting. Many concepts we are learning. So if you see, we talked about the general term of a matrix Aij, where the first number denotes what? The row number, and the second number denotes the column number. We started with that. Then I talked about the applications of matrix. And then if you see page 2.36 of your study material, you will see a wonderful example of Ram, Sita, and Lakshman. Ram has 5 books, 3 pencils, and 2 pens. Sita has 10 books, 8 pencils, and 5 pens. Lakshman has 15 books, 10 pencils, and 2 pens. So in the Board of Studies example taken in the study material, it has been beautifully shown how to represent this information in a matrix. You can see page 2.36 of the study material. So we also saw that the order of a matrix means the number of rows multiplied by the number of columns. So m into n means there are m rows and n columns, right? And what do you mean by a matrix? Matrix is a table of numbers. You can call it a rectangular array of numbers. And what is equal matrix? Equal matrix will be, 2 matrices will be equal when they have the same order and the same corresponding element. Some of you could not understand corresponding element. Corresponding element means each element in each position in one matrix, the same element should be there in the same position in the other matrix, right? then we call it an equal matrix. And we have seen how to create transpose of a matrix. Right. Then we have seen what is a row matrix. Row matrix means only one row, a matrix with only one row. Column matrix is what? A column matrix means a matrix with one column, and zero matrix. So this was an example of zero matrix where we saw that every element of the matrix is 0. 2 by 2, 3 by 3, 2 by 3. And we have thereafter we have seen what is a square matrix and what is a rectangular matrix. I have explained to you that if the number of rows in a matrix is also equal to the number of columns, so m into n, if there are 2 rows and 2 columns, it's a square matrix. 3 rows and 3 columns, square matrix. 4 rows and 4 columns, square matrix. But 3 rows and 2 columns, no, it is not a square matrix, it is a rectangular matrix. 4 rows, 3 columns, is it a square matrix? No, it is a rectangular matrix. Fine. Now we proceed to learn what is scalar matrix. Okay. Acha, before that, I will show what is diagonal matrix first, and then we will see what is a scalar matrix. Principal diagonal, you know. Now let us see. I will create diagonal matrix. Okay. So please write with me. We are writing diagonal matrix. So I write a matrix, say S, like this. 3 0 0 0 6 0 0 0 9. Please see the matrix. 3 0 0 0 6 0, and then it is, I have written 0 0 9. Okay. Okay. Shubham, I have seen your question. We will sub-matrix we will do later, right? Nafisa, even a single 0 is called a zero matrix. Only a single 0. No. Okay. Right. Okay. So now if you see, so 3 0 0, and then you have the number 0 6 0, and then you have 0 0 9. So if you see, this is a particular matrix where only the principal diagonal, you see the principal diagonal, we are having 3, 6, and 9. All the other numbers are 0. Okay. So if you see 3 0 0 0 6 0 and 0 0 9, if you see here, only the principal diagonal 3 6 9 you have. All the other numbers are 0. So this type of matrix is called a diagonal matrix, where we only have numbers on the principal diagonal and the other numbers or the other elements are 0. So this is called a diagonal matrix. All entries outside the main diagonal are 0. So in that case, it is called a diagonal matrix. Let me take another example. So I will draw another example here. So let me take -5 0 0 0 6 0 0 0 -9.5. Is this a diagonal matrix? Answer is yes, because the principal diagonal, only the principal diagonal, the elements on the principal diagonal are numbers. It can be, of course, you can see it can be fraction also, it can be a mixed number, right? It can be a decimal, it can be a negative number, -5, for example. So this is the principal diagonal. This is the principal diagonal. Okay. All the elements, all other elements which you see here, all other elements are outside. All the other elements which you see outside the principal diagonal are 0. That means this is an example of what? This is an example of diagonal matrix. Okay, so all the elements outside the principal diagonal are 0. I hope you have understood. Now we will learn what is a scalar matrix. So please keep noting the points which you are learning so that you are clear with the idea. Now we take up scalar matrix. Now what is scalar matrix? You saw in this example, let me take one more example here. I will draw a diagonal matrix and I will also draw a scalar matrix. Scalar. Then you will understand the basic difference. I am drawing a diagonal matrix first. I am taking the matrix 5, 0, 0, 0, 3, 0, 0, 0, minus 6. Left hand side. Please see. I am taking the name, I am giving it a name A. Matrix A, we have 5, 0, 0, 0, 3, 0, and then you have 0, 0, minus 6. Now, is it, what type of matrix is this? Who will say? Okay. Please note that whenever we are drawing this diagonal matrix, ideally, you see the matrix has to be a square matrix. Okay, a rectangular matrix cannot have a diagonal matrix. Okay, so always remember that it has to be, whenever we are drawing a diagonal matrix, as per the definition of diagonal matrix, it has to be a square matrix. Right. Now let us see this example: 5, 0, 0, 0, 3, 0, 0, 0, minus 6. Is this a diagonal matrix? Yes or no? I think yes, because the numbers on the principal diagonal, which you see here, the numbers on the principal diagonal, only these numbers, right? These numbers are non-zero numbers. They are not equal to 0. All the other numbers are 0. So the numbers which are outside the principal diagonal are all 0. So it's a diagonal matrix. Now, what is scalar matrix in that case? The scalar matrix is very simple. It's a diagonal matrix where all these three numbers are equal. Okay, so if I draw a scalar matrix on this side, let me take an example. It will be clear in a few seconds. So I'm drawing a matrix here: 6, 0, 0, 0, 6, 0, 0, 0, 6. This is a scalar matrix because, why it is a scalar matrix? Because the numbers which you see here on the diagonal, principal diagonal, are equal, and all of them are equal to 6. So this is an example of a scalar matrix. So we can write, friends, that scalar matrix is a diagonal matrix. It is a type of diagonal matrix where all the elements on the principal diagonal are equal. Okay, I hope you have understood what is diagonal matrix and what is scalar matrix. Right? I hope it is clear. This is the principal diagonal. All the elements outside the principal diagonal are 0. 0, 0, 0, 0, 0, 0. So this is a diagonal matrix. Now, in case of a diagonal matrix where all these elements are equal, it is called a scalar matrix. Right? Now we will see what is identity matrix. So instead of 6, 6 and 6, if I write these numbers 1, 1 and 1. Now please see 1, 0, 0, 0, 1, 0, 0, 0, 1. The moment I write this, this matrix becomes, it is no longer called a scalar matrix. It is now known as identity matrix. Identity matrix, because you know, identity, the word identity means 1. Okay. If a number is increased by identity, that means if a number is increased by 1. Okay. So this is an example of identity matrix. So you see that identity matrix is a type of scalar matrix where all the numbers on the principal diagonal are 1. What is a scalar matrix? A scalar matrix is a matrix where all the numbers on the principal diagonal are equal. Okay, so you see the connection between diagonal matrix and scalar matrix and identity matrix. Please note this connection. A scalar matrix is definitely linked with diagonal matrix. So we can say that a scalar matrix is a type of diagonal matrix where we have the elements on the principal diagonal are all equal. Identity matrix is a type of scalar matrix where we find that the number on the principal diagonal is equal to 1. Okay, so diagonal matrix, scalar matrix, and identity matrix are linked. They have a link. Okay, I hope you can see the link now. Right, so many terms we are learning, and I think you can see that many terms we are also adding in our vocabulary. Now, is identity matrix, yeah, so question has come from Aryan. Yes, is identity matrix is a scalar matrix? Yes, identity matrix is a type of scalar matrix where we have each number equal to 1. Fine. Okay. Now we move on and we look at unit matrix. I think we have done already. Unit matrix is also known as identity matrix, right? So yeah, when I was explaining zero matrix, you see zero matrix is also known as null matrix. Okay, like Mohak was asking, Mohak Agarwal, yes. So zero matrix is also known as null matrix. So if you have a matrix like this, 0, 0, 0, 0, 0, 0, say the matrix is X. So this is called a zero matrix, okay, or it can be a null matrix. Okay, both the names are used. Fine. Now we proceed and we look at the next point, and that is upper triangle matrix and lower triangle matrix. So we are now basically discussing the important point, which is there in page number 2.38 of your study material, 2.38. We are discussing about upper triangle matrix and lower triangle matrix, 2.38. Now, what is an upper triangle matrix? Let us see. So I will draw an upper triangle matrix and then we will understand upper triangle and lower triangle. Okay, so I will draw upper triangle matrix, upper triangle, and then we will see a lower triangle. We'll draw a lower triangle. Upper triangle matrix. Let us draw. Let us draw up a matrix 1, 6, 5. Let me take numbers 0, 3, 4, and let me take 0, 0, 007. 007, you know, is the secret number of James Bond, right? 007. So I've taken 007. Okay. So 165, 034, 007. Now please see that here the principal diagonal, right? Leading diagonal, also known as principal diagonal. This is the diagonal I'm just drawing. Okay. I am sure you will agree to this. This is the leading diagonal, or this is the principal diagonal. Please see the elements below the principal diagonal are 0. All of them are 0. But the elements above the principal diagonal, they are numbers. They may be positive numbers or negative numbers, but they are numbers. So you have 6, 5, and 4. So upper triangle matrix is a matrix where the elements below the principal diagonal are all equal to 0. Okay, I hope you have understood. Every element below the principal diagonal will be 0 in case of an upper triangle matrix. That means as if the upper part is having a triangle with numbers. So that's why it's called an upper triangle matrix. Now we will do the reverse. We will look at a matrix which is just opposite to this matrix. So it is called a lower triangle matrix. So lower triangle matrix, just apply your mind. If upper triangle matrix means that the elements below the principal diagonal will be 0, then lower triangle matrix means the opposite. It means that a lower triangle matrix will be a matrix where the elements Here it was below, but now it will be above, where the elements above the principal diagonal will be 0. Right? It's just the opposite. It's just absolutely the mirror image. So let us draw, let us write a particular matrix. We'll take a matrix here. Let the matrix be X, and the matrix is like this: 1 0 0, 6 7 0, 7 9 8. Just see this matrix. The principal diagonal you can see is this 1 7 8. This is the principal diagonal. I hope you can see this clearly. 1 7 8 is the principal diagonal, and the elements above the principal diagonal is 0 0 0. So this is an example of a lower triangle, as if there is a lower triangle here, right? This is an upper triangle, this is a lower triangle, right? I hope you're following and you're understanding. So you see there are a number of types and terms to be learned, right? Unit matrix and identity matrix are same. Yes, Pooja, Zifa, yeah, your questions. Pushpa, identity and unit matrix are same. Identity matrix and unit matrix are same, right? So, right. Manish Kumar has asked, scalar matrix, identity matrix, diagonal matrix must be square matrix. Yes, you cannot have diagonal matrix in case of a rectangular matrix, right? Now, Atharv Gupta, what is the object of matrix? Yes, the object of matrix, we will see after some time, is to solve equations. Plus, it has a lot of applications in economics. In later on, when you go into IPCC and final in CA, you will study a paper on financial management. In fact, a little part of it you already have started with your BCK paper. So there you will find tremendous applications of matrix algebra, especially in the case of investment management, financial modeling, and of course, corporate finance. Right. Okay. Yeah, sub-matrix will do. Just hold on for some time. Yeah, Pooja is saying this chapter is easier than equations. Yes, so far it seems easier. I'm sure it will be easier than equations. So just I'm speaking just like a story we are discussing, and each of the points is good to see that you are following. Now we come to sub-matrix. Okay, I think someone was writing about sub-matrix. Acha, Simran is asking, she's from South Delhi, there can be 2-digit numbers. Yes, there can be 2-digit numbers also. I can take a matrix like this, for example, 25 minus 1, 0. Okay, then say minus 7.521, 9, like 4.75 and 6. Okay, Simran, I hope you are seeing. Okay, so this is also a matrix. It can be any numbers, right? Of course, the real numbers we are taking. It can be positive, negative, mixed fraction. It can be only fraction. Okay, no problem. Fine. So we have talked about equal matrix. Okay. Soumya Gupta from Bilaspur, Chhattisgarh, my friend. Sir, cubic equation and quadratic equations are important. Please reply, sir. Yes, I'm replying. It is very important. Please study it. Do not leave it, because quadratic equations, I don't want to go into that revision now. I have just noted before I started the session, I was going through the model test paper of October 2020. I found 4 or 5 problems only on equations. So 5 marks. So I think it's not a matter of, we cannot be casual with 5 marks in an exam like CA. So Soumya Gupta, I will request you to please go through the equations chapter, and cubic equation, quadratic equations are important, right? Okay. Okay, many points are coming. Okay, let's go into the next, and now we will see submatrix. Yes, I think who was asking about submatrix? Just a moment. Equivalent. Okay. Submatrix. Yes, I think someone was asking about submatrix just now. Yes. Okay. So submatrix is very simple. From a particular matrix, you create like from a bigger chunk of a cake. Say you are having a big party cake, right? Tomorrow, of course, is a very important day for young people, Valentine's Day, and wishing all of you a happy Valentine's Day now. But then you remember that on Valentine's Day, we had the chocolate day. You have a big slice of cake, okay? And I ask for a small bite. So you give me a piece of that. That is a submatrix. I will show you what is matrix and submatrix. Okay. This chapter is really easy. And if you see, all the chapters in mathematics are fairly easy. If you love mathematics and if you just follow the basic rules and practice, I think the paper is indeed very, very interesting and scientific and practical, right? So I will create a submatrix, right? So I have a matrix. Let me take a matrix 767. Then let me take 320 and 541. This is a matrix. Okay, I'm taking the matrix. I give it a name P. What type of matrix is this? Is it a rectangular matrix? No. How many rows are there? 3. How many columns are there? 3. So it is a 3 by 3 square matrix. Now what I will do is, this is like a cake. So imagine it is like a big birthday cake, right? Or, you're having some cake here, right? So it's like a birthday cake. I'm asking for a small slice of the cake. You give me a small slice of the cake. Similarly, in this particular, matrix, if I delete small slice of the cake, means you'll give me a piece of the cake. So from here, I will create a piece. What I will do is, let me block this row, this column and this row. Okay. So what I'm getting 7, 7, 5, and 1. So I am getting a new matrix 7, 7, 5, and 1. As simple as that, my dear friends. This is a submatrix. Okay. It's like asking for a piece of cake from a bigger part of a cake. I'm asking for a slice of cake. Okay, so this is 7751. This is a submatrix. Okay, so we can delete. Remember that we can delete. Here I've deleted 1 row and 1 column. You can also just delete 1 row. That is also possible. Let me show you. So this is technique number 1, where I'm deleting 1 row and 1 column. So let me take this example now and see how to create a submatrix. So I will take an example: 5, 6, minus 1, 3, 0, minus 4, minus 5, 2, 8. Okay, fine. This is a square matrix, 3 by 3. Okay, please see, 3 by 3. Now, in the last example, I had deleted a particular row and a particular column. This time, let me delete one particular row. Okay, which one? 1, 2, 3, 1, 2, 3, 3. Okay, I'll take 3. I'll delete 3, row number 3. I've eliminated row number 3. So what do I get from here? I get another matrix, that is 5, 6, minus 1, 3, 0, minus 4. 3, 0, minus 4. Please note that the submatrix which I have got is having 2 rows and 3 columns. So it is a 2 by 3 matrix, whereas the original matrix was a square matrix. It was 3 by 3. Okay, so the original matrix was a square matrix. The new matrix, which is nothing but the submatrix. It is a submatrix, fine, but then it has become a rectangular matrix because it is having the order 2 by 3, right? So this is submatrix, right? Now we will take submatrix in rectangular matrix. Okay, so up till now we were discussing square matrix. Now we shall see a rectangular matrix and we will create a submatrix. Fine. So I hope you are all learning with fun. Most important thing, any subject, mathematics, economics, accounts, you have to learn with fun, learn with enthusiasm, and that's how you become better professionals, right? So now we take a submatrix of a rectangular matrix. I will take a rectangular matrix first. So let me take a rectangular matrix. Let me call it Q, and I will take a rectangular matrix. So let me see. I'll take a 4 by 3 matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I hope you can see the matrix. This is, I have taken a 3 by 4 matrix. So we have got 3 columns here, 3 by 4. Okay. I have taken a 3 by 4 matrix. Now, I will try to cover, or I will try to remove column number 2 and row number 4. Sorry, I'll remove row number 3. Let me remove row number 3 and column number 2. So what I will do is I remove row number 3, first row, second row, third row. I remove third row, and I will block column number 2. So first column, second column. So what are the numbers which are now visible? 1, 5, 3, 4, 7, and 8. So we get a new submatrix, and the submatrix is 1, 4, 5, 7, 8. That's it, nothing else. That's it. Okay, so we have taken a 3 by 4 matrix. From there, this was a rectangular matrix. We have got a submatrix, and the submatrix is how much? It is 2 rows by 3 columns. It's 2 by 3. Original we had 3 by 4. From 3 by 4, we have gone into a submatrix, and we have got a 2 by 3 matrix, 2 by 3 submatrix. Okay. I hope you are following. Right. Okay, submatrix, many of you were asking, Vishwabandhu Mohanty, Mohak, then, yeah. Acha, Rajiv Kumar Ranjan, previous question, kahan milega? He is from Bihar. Previous year's question you will get online. Different websites are there. You can check the ICAI website also. We have got multiple websites. ICAI is having multiple websites. You can see BOS activities website, ICAI Cloud Campus, many websites. You will get the previous year's question. Okay. Good. So Sneha has a question, sir, in submatrix, 1 row and 1 column are deleted. Sneha, it can be 1 row, it can be 1 column, it can be 1 row and 1 column also. Like I took the example, here you see I have deleted 1 row and 1 column. Let me take another example, Sneha. 0, 3, -1, 2, 4, 6, 9. Okay. This is another matrix. Okay, Sneha, I hope you are following and watching. I will delete only 1 row. Let me delete first row. Okay, I delete first row. So what is the matrix I'm getting? The new submatrix which I'm getting is what? I'm getting 3, -1, 2, 4, 6, 9. This is also submatrix. So original matrix, you can delete either a row or a column or both row and both column. You got it? Either a row or a column or a row and a column. Right? I think, Sneha, you have got it now. Okay. Okay. Tanu Chandrakant Gupta from Mumbai. How to know which row or column we have to delete for getting submatrix? Okay. No, they will tell you in the question. Don't worry, they will tell you. In fact, if a question comes that this is a matrix, you have to create a submatrix, they will tell you that, okay, you delete row number 2, column number 3. Okay. Don't worry on that. Okay. Great. We are getting number of interactions and questions. Okay. After submatrix, I will take the example of equal matrix. Okay, equal matrix I have already explained. Now I will take an example, so you will be absolutely clear with equal matrix. This chapter is quite long. The only thing is, it takes time to cover this chapter in detail. Still, we are trying our best. Now, equal matrix, I will draw 2 matrices. P. Let me take easy one, small one. 2, 6, 1, 0, 5, 3. I'm taking another matrix Q, 2, 6, 1, 0, 5, 3, and I am taking another matrix R 2 6 0 5. Let me add one more. 2605. Let me add here. No, I'll do it in this way. 261053. This is more interesting now. Okay. Please pay attention, my friends. Please pay attention to these three matrices in front of you. Now you will easily understand. Okay. What I said earlier, many of you were asking questions on equal matrix. Two matrices will be equal under two conditions. Condition number one, the order of the matrix must be same. So if matrix A is 2 by 2, matrix B has to be 2 by 2. If matrix A is 4 by 3, matrix B has to be 4 by 3. First condition. Second condition, corresponding number should be equal. I think some of you had difficulty in understanding this part. I kept the difficulty deliberately so that I can explain you now. Now you have better idea. So that's why I didn't explain you at that point of time. We will explain it now, and now you will get it very easily. So I will request you to tell me P and Q. P, what is the what is the order of P? It is how many rows? 2 rows, 3 columns. So I'm writing 2 by 3. Q, how many rows? 261053. 2 rows into 3 columns. Okay, no problem about that. Now you see corresponding position of each element. First element is 2. Okay. So 2 basically is what? A11. Row number 1, column number 1. Here also 2 is A11. 6. Here 6 is A12. Here also 6 is A12. Third is A1. 1 is having the number A13. That is row number 1, column number 3. Here also 1, 3. I hope now you are getting what do you mean by corresponding element. Corresponding element. Okay. So 261, we have the same sequence 261. 053, 053. So can I say now that P is equal to Q? What do you think? Let me see the chat box. Can I say that P is equal to Q? Nafisa from Tamil Nadu, yes. P and Q are equal matrix. Yes, correct, you are. Ikshit from Bhopal, can we delete more than one row or column? Yes, we can delete more than one row or column. Ikshit, no problem. Vijay, can we delete 2 or more rows and columns? Yes, we can delete 2 rows. If you have a 5 by 5 matrix, okay, or a 5 by 4 matrix, you can definitely delete 2 rows, 3 rows, 2 columns, any combination. Okay, good that questions are coming. Archana from Karnataka, which type of questions we get in the exam? Yeah, you will get one question on addition. You will get one question maybe on transposing, and definitely the most important part, determinants and Kramer's rule. But my dear friends, to understand determinants and Kramer's rule, this everything you must know. Okay. Similarly, a question came on transpose. So you must know transpose. I have explained it. Equal matrix we are learning now. So all these are important for the exam. Okay. Now, so I think P is equal to Q. Yes. So Gunjan from Chhattisgarh, Moksha from Maharashtra. Yes. So it is coming, right? It is, you are all correct. P is equal to Q. A small question from Karishma. From where CA Monthly Magazine to look? Karishma, just go to ICAI.org, go to the student section. I will tell you the best thing. Go to Google, just type ICAI CA Students Journal. ICAI CA Students Journal. You will get the link. You can download the February journal. Below that, you will find there is a small word which is written archive. Archive means what? Old edition. So all the past edition till January, you will get in the archive. Please go through it. Not just to Karishma, but to each one of you. I request you to go through it. It will help you. Okay, you will find a lot of important information and explanation, right? And questions on every subject of the foundation. Important for the exams, right? So P and Q are same. Great. Anchal also has written. Now my second question is 261053. Now you understand? Each element is there in Q also, and the position, the corresponding position is also same. Plus they have the same order, 2 by 3, 2 by 3. Now, so P is equal to Q. I think this is agree. You will agree and everyone will agree. Now I will request you, dear friends, to please see. So Q I am removing. Q is out of the picture. Q is same as P. Can you now tell me P and R? Are they equal also? 261053. I also have written 261053. But are they equal? Same elements are there. How many elements are there? 6 elements. Here also 6 elements. The same elements are there. 261053. Here also I have 261053. So they must be same. What do you think? Is P and R equal matrix? Let me see whether anyone has written. Yes. Acha, Shaurojit Bonik from Kolkata. What can be the limit of a matrix? No limit. It can be 50 by 40, 30 by 20, but don't worry. Those things you will do in a computer. For the time being, for exams, maximum 3 by 3. Okay. So we will see the questions, you will understand. But there can be no limit on the matrix because you see, you think of Excel, right? All of you know MS Excel. The moment you open Excel, what do you see? Columns and rows. It can be thousands of rows by thousands of columns, right? Okay. Bishwabandhu Mohanty, sir, can a matrix have no elements? Well, a matrix may only have 0, right? Only 0 means null matrix, but a matrix with no element, no, that is not possible. There must be some element. It can be 0, but some number should be there. Okay. Okay, I've got the answer. Amol Gupta, thank you. Divya Bhansari from Gujarat, Karishma, Shubhasri Mohapatra from Odisha, and Moksha. Very good. Thank you. Thanks for giving the right answer. P is not equal to R because of 2 reasons. Reason number 1, you see the elements are same. 261053, here also 261053. But here the order was 2 into 3. Here the order is how many? 3 rows and 2 columns. So order is 3 into 2. So therefore this is not equal to this. Excellent. Thanks, my friends, for giving the right answer. Okay, now we will do an exam question. Some of you are asking. Definitely the question which comes in our mind, the exam mein kis tarah ka question aayega? So let me take the exam question on equal matrix. This has come in the exams. Okay, I will request you to note the question and try to answer. This has come in the CA exam. Let me write the matrix. The matrix is like this: x plus 3. Let me see the question. Okay. -1, 4, and 5. And this is equal to another matrix given 6, y, z minus 3, and 5. Beautiful question. Very beautiful question. You have to find the value of x, y, and z. We have to find the values of x, y, and z. I hope you can see the question. Okay, x, y, and z, you have to find the value. It is given that this matrix is equal to this matrix. Okay. So now can you find out the values? So you know the condition for equal matrix is there are 2 conditions. First is that what are the 2 conditions? The conditions are they must have the same order and they must also have the same corresponding element. So in this case, the equation x plus 3, this expression x plus 3 must be equal to 6. So x plus 3 equal to 6, which means of course x is equal to 3. Then you see y, and the corresponding number is -1. So y definitely has to be equal to -1. And then you see the third point, z minus 3 is here, and the corresponding element is 4. So I will write z minus 3 equal to 4 or z is equal to 7. As simple as that, right? I hope you are getting the confidence and understanding. This is equal matrix. Okay. Now we go to symmetric matrix. Interesting. Symmetric and skew symmetric. Symmetric and skew symmetric, and then we will go into determinants. Fine. Symmetric matrix. Okay. Now let me take an example. I take an example A, matrix A, and the matrix is like this. Let me draw it. 1, 7, 3, 7, 4, minus 5. 3, minus 5, 6. 1, 7, 3, 7, 4, minus 5. 3, minus 5, 6. Can you find out its transpose? We are trying to understand what is symmetric matrix. Let me write. What is symmetric? What is symmetric matrix? We are trying to understand this. What is symmetric matrix? Now, can you help me to find out the transpose of this AT? We know this matrix A. Once again, I'm repeating 1, 7, 3, 7, 4, minus 5, 3, minus 5, 6. Can you help me to find out the transpose of this matrix? Transpose. Okay. Can I work it with you? I think, yeah, good answers are coming. Very good, very good. A lot of answers are coming. Great. Very good. Good. Ikshit has asked, what is the lower limit of matrix? Lower limit of matrix normally you deal with will be 2 by 2 matrix. Of course, you can have a row matrix and a column matrix as well. Okay. So, can I do the transpose with you? Let me try. I hope I am not forgetting so many things we are learning. Okay. So in transpose matrix, what I'll do is I will keep 1 here. This 7 will come here. The 3 will come here. This 7 will go up. This 3 will go up. So I'm getting 1, 7, 3, and this 7 is coming here and 3. 4 will remain as it is. Minus 5 will go here. Minus 5 will come here. Minus 5, and 6 remains as it is. Please see if the transpose is correct. Have you observed anything? The observation is, in this case, A is equal to A transpose. Just see, both are same matrix. So, this is an example of a symmetric matrix where the transpose of the matrix is equal to the matrix. This is called a symmetric matrix. Okay, just check. The original matrix, I have got the transpose, but the transpose is also the same, identical matrix. So this is called a symmetric matrix. Okay, this comes as a question sometimes. So what is symmetric matrix? There may be 4 alternatives given. Okay. Now we go to what is skew symmetric matrix. Okay, so this is symmetric. Now we learn what is skew symmetric, and then we will go into determinants. And then Kramer's rule, with which we shall end today. Right. Now, friends, we go into skew symmetric matrix. I will take another matrix example. Skew. I add the word skew. S-K-E-W. Skew means what? Skew means unbalanced. Okay. Let me try skew symmetric matrix and see. I'm writing a matrix, and matrix is A. Let me take matrix. Let me draw a matrix. The matrix is like this: 0, 2, 0, 2, minus 45. 0, 2, minus 45. Then I will write minus 2, 0, minus 4. And I am writing 45, 4, and 0. Please see the matrix. 0, 2, minus 45. Minus 2, 0, minus 4. 45, 4, and 0. What type of a matrix is this, my dear friends? It is a square matrix. because the number of rows are 3, the number of columns are 3, it is a 3 by 3 matrix. 3 by 3 matrix, which means it is a square matrix. No question about it, no doubts about it. Now we want to find the transpose of the matrix. So we want to find AT. What will happen if I move into AT? This -2 will go here, the 2 will come down, 45 will go up, -45 will come down. So I'm writing 0, -2, 45. This 2 comes down here, this 45, -45 comes down here. So -45. Okay, I hope you can see, and I'm doing it with you. 0 remains 0, -4 comes down, so it comes down here, and this 4 goes up. This 4 goes up. 0 remains the same. Now please see the matrix which we have got. Please see the matrix very carefully, my dear friends. Look for the sign, that is the sign, positive, negative. Here it was 0, 2, -45. Here it is 0, -245. Row number 2 we had -2, 0, -4, but here we are having 2, 0, 4. Third row we had 45, 4, 0, but here we have -45, -4, 0. So can you see that A transpose is nothing but -A? That means all the sign in A has been changed. 2 was positive, here 2 is negative. 45 was negative, -45, it is positive. Here -4, here +4. Here -2, here +2. Here 45, here -45. Here it was 4, here it is -4. Can you see? And I hope you can appreciate and understand, right? So this is called a skew symmetric matrix. That means any matrix whose transpose gives you the negative of the original matrix. Okay, so symmetric matrix means what? If A is equal to AT, if A is equal to its own transpose, then it's a symmetric matrix. If AT is equal to -A, then it is a Q symmetric matrix, right? Fine. I think no problem with this, and you are able to understand how we write symmetric. And yes, many of you, Jai Shri, Karishma, Priyanshi, yes, many people have given answers. Manvi, Pooja, Sneha, yes, very good. Excellent, great. So this is symmetric and Q symmetric, skew symmetric. Okay, now we start with determinants, a new part of our syllabus in this chapter, of course. So we have completed the foundation after exactly 1.5 hours. We started sharp at 2, it is exactly 3:30 now. We took 1.5 hours to create the foundation. Of course, from this foundation, number of questions will come, definitely. Okay, and you see the concepts are important. Now you're absolutely clear what is matrix, order of a matrix, what is equal matrix, what is 2 by 2 matrix, 3 by 3 square matrix, you know, rectangular matrix, you know. Then we have done what else? We have done scalar matrix, we have seen diagonal matrix, we have seen. Okay, and we have also discussed about unit matrix or identity matrix. Fine. Now we look at determinants. Now, determinant, please note, friends, determinant. Okay. Determinant means when you have a square matrix. Okay, always remember that determinant can be created only from square matrix. It has to be a square matrix, that is 2 by 2, 3 by 3, 4 by 4, and so on. Now let me take a simple example. It will become very clear. I am taking a 2 by 2 square matrix. Okay, I'll call it A. Give me some numbers. 3, for example, 3, 7, 4, and 6. Okay, sweet little 2 by 2 matrix. 3, 7, 4, 6. This is a matrix. Now, determinant of this matrix will be what? So we will write it as DETA, determinant of A. Very simple, just cross multiply. 3 into 6 minus 4 into 7. As simple as that. This is called determinant. So it is a number which is associated with a square matrix, and we do this. So left to right first, 3 into 6, 18. And from there we subtract the right to left to right. So left to right, and this is right to left. 3, 6 is left to right, 7, 4 is right to left. 3, 6 is left to right, my left to the right. 7, 4 is right to left. 3 into 6 is 18, minus 4 into 7 is 28. So you get minus 10. This is determinant. Okay, now I will take one more example. So it is nothing but a number which is associated only with a square matrix, because you see we are cutting diagonally. So if you have a matrix like this, say 3, 7, 6, 4, 1, 2, sorry, no determinant is possible. Okay, because you need diagonals, you need 4 numbers ultimately. Of course, we will see determinant of 3 by 3 also, but 2 by 2, it has to be square. Idea is that determinant of any matrix can be found out only if the matrix is a square matrix. It can be 2 by 2, it can be 3 by 3, it can be 4 by 4 also. For our exam, please note up to 3 by 3 is important, 2 by 2 and 3 by 3. Okay, now we will see another example of a square matrix, and we will find out the determinant. And let me see if some of you are fast enough to do it for me. I will write another matrix B, and B is equal to minus 5, minus 4, minus 2, minus 3. Please find out the determinant of B. Okay. I will just have a sip of tea, and then let me see if you can quickly work it out. So as usual, what to do? Left to right. So minus 5 into minus 3. My dear friends, please be very careful about the sign here. Once again, positive sign, negative sign. Minus 5 into minus 3 is 15. Minus 2 into minus 4. So you have minus 2 into minus 4. So this is 15 minus 4 to the 8, which is 7. Let me see if anyone has got the answer. Yeah, answer is 7. Amol Gupta, minus 17. No, my dear. Vijay has got minus 7. No. Steffi, 22. No. Minus 5 into minus 3. So 5 into 3, minus 15. Minus 4 into minus 2. So it is 8. So we get 7. Okay. It is 7. This is only one example. Okay. Now, just understand the concept of determinant. Okay. We will do it a little later. Now we will look at the algebra of matrices, which is addition, subtraction, and then we will do more of determinant. I just wanted to give you the idea of what is determinant and how to find the determinant. So always remember this, okay, left to right minus right to left. Left to right minus right to left, okay? And be very careful about the sign, positive sign and negative sign. Now we go into another very simple area. Back to just, we looked at determinants a little bit. We saw a snapshot of it. Now we will do some simple example of addition of matrices, algebra of matrices. Okay, algebra. So algebra means first is addition, then subtraction, then multiplication. So first let us do the addition. Addition of matrices. Okay, very simple. Do with me. Let me write two matrix A. A is equal to 1, 3 minus 2. Then I'm taking 4, 2, 3, 4, 2, 3. And I'm taking minus 1, 5, and 4. This is A. Okay. Now I will write another matrix B. B I'm taking 5, 2 minus 1. 5, 2 minus 1, 3, 1, 2, 3, 1, 2, 4, 3 minus 2. Now C is equal to A plus B. You have to find C. That means you have to do the addition. Very important exam question. These are very, very important for your exams. One question from addition or subtraction is definitely expected. So we will just add. Very simple operation, nothing to worry about. So the first example is how many rows and how many columns? 3 by 3. So it is 3 by 3. Second matrix B, 3 by 3. Okay. So we will write C and we will add. Please follow carefully as I go on adding. I take the first number, element 1, here it is 5. 5 plus 1 is 6. I take the second one, 3. Here it is 2. 3 plus 2 is 5. I take the third one, minus 2, it is minus 1. Minus 2 plus minus 1, that is minus 3. First row is over. I move to the second row. Please see. 4, here it is 3. 4 plus 3 is 7. 2 and 1. 2 plus 1 is 3. 3 and 2. 3 plus 2 is 5. I move to the third row. I have minus 1. Here I have 4. So minus 1 plus 4. That gives you 3. Next is I have 5. Here it is 3. 5 and 3 is 8. And the last one is 4. And I have 2 here, minus 2 here. So 4 minus 2 is 2. This is the addition. So we have got another 3 by 3 matrix. This is the addition of the matrix A and B. 6, 5, minus 3, 7, 3, 5, 3, 8, 2. I hope it is clear. You have understood the process. Absolutely very easy. Just add the corresponding number. This is the meaning of corresponding. 1 with 1, this number, second number with second number, third number of the first row with third number of the first row. Don't mix up. Don't add 4 with 1 here. 4 has to be added with 3. This minus 1 has to be added with 4. Corresponding. Okay, corresponding numbers. This is matrix addition. Now we will go into matrix. Let me take another matrix. Okay, and I request you to try and add, if you can add the matrix. Okay. So we just see addition, multiplication, and subtraction. Now we look at addition. We take another example. This time we will take F. Say F is 1, 2, 3, 4, 6, 7. So it is how many rows? It is 3 and 2 columns. So 3 by 2. 3 rows and 2 columns. I am taking G. Okay. G is another matrix. I take 1, 0, 1, 1, and let us take 0, 1. You have to find F plus G. Let us see if you can do it on your own. So, working together, this one and this one, add 2. 2 plus 0, 2. 3 plus 1, 4. 4 plus 1, 5. 6 plus 0, 6. 7 plus 1, 8. Finished. The addition is done. This is what is addition of matrix. Okay, I think you are getting it and you are clear. Great. Many people are working with me. Great. Simran has a question. Can we add matrices of different orders? No, you cannot add matrices of different orders, right? So please remember that matrices we can only add of the same order. Okay, good, intelligent question. Dikshita from Hyderabad. Sir, a matrix with one element can be called as the square matrix. One element. No, it's not a square matrix. Okay, now we go to subtraction. Now let us see a subtraction example as simple as that. Just the opposite of addition you will have to do, and then we will quickly go into multiplication and then determinants and Kramer's rule. Now we go for subtraction. I will take two matrix. A is 5, 2, 3, 5, 2, 3, 1, 2, 7, 1, 2, 7. Okay, this is matrix A. I am taking matrix B, 6, 7, minus 2. 6, 7, minus 2. 3, 5, 3, 5, and 19. You have to find A minus B. So you're subtracting B from A. Okay. So let us do the subtraction. Same rules. We consider the corresponding elements. Okay. Please work with me together. Let us solve it. So this will be equal to, I'll take the corresponding 5 minus 6. Okay. How much is that? 5 minus 6 is minus 1. I write minus 1. Taking the next number, here we have 2, here we have 7. 2 minus 7. How much? Minus 5. 3, and here we have minus 2. So as I told you, be very careful about the numbers as well as the sign. Here we have 3, here we have minus 2. So 3 minus minus 2. So it becomes 3 plus 2, that is 5. I move to the second row, 1 here and 3 here. 1 minus 3 is how much? 1 minus 3 is how much? Minus 2. So I write minus 2. 2 here, okay? And we have 5 here. 2 minus 5, how much? Minus 3. 7 and 19. 7 minus 19, how much? Minus 12. So I write minus 12. Complete. This is subtraction. Okay. Is it difficult? I don't think it's difficult for you, right? Definitely you are able to understand, and you can see very simple concepts, and these will be important points from where questions might be coming. Acha, now we go to the last part, that is scalar multiplication, and we see the multiplication. So we are completing the algebra of matrices, addition, subtraction, and the multiplication. Now we go to multiplication. In multiplication, we will have two types of multiplications. So the first one we do is called a scalar. Okay, scalar multiplication. Scalar, SCALAR. Scalar multiplication. What is the concept of scalar multiplication? Very easy concept. Let me take a simple 3 by 3 matrix, calling it S. Simple 3 by 3 matrix, 5 minus 1, 0, minus 3, 2, 7, 9, minus 8, and 6. 3 by 3 I have taken. Okay. I will also take a constant number with which we will multiply this matrix, and that is K. So let K be 3. Okay. Then what will be the product? K into S. What we will do is we will multiply 3 with each of the numbers in the matrix. So I will draw the product matrix like this. 3 into 5, how much? 15. I'll write 15. 3 into minus 1, minus 3. 3 into 0, 0. 3 into minus 3, minus 9. 3 into 2 gives me 6. 3 into 7 gives me 21. 3 into 9, I go to the third row now. 3 into 9, 27. 3 into minus 8, how much is that? Minus 24. 3 into 6 is 18. But it's as easy as that. You've got your scalar product. Okay. So this is the way to carry out addition, subtraction, and scalar multiplication of matrices. Okay. Now we will take up multiplication of matrices. This we have to little bit understand, and we will also see a very important rule of multiplication. Okay. So just review the scalar multiplication part. Good. Many of you have given answers. Okay, good. Okay. Amina from Kerala. See, one just having a matrix like this, 2. Okay. This is not a square matrix, right? Square matrix, we always have 2 by 2, 3 by 3, 4 by 4 like this, right? So these are, don't think these questions also will never come. One element, we cannot call it a square matrix. There are certain definitions. I hope you understand now. 2 by 2, 3 by 3, 4 by 4. You will never hear about a 1 by 1 matrix. Okay. Scalar matrix I have explained, Anjali. Okay. Yeah. Paridhi, you are saying, let's see multiplication next class. Sorry, next class we have to go for inequality. This is a big chapter and we have to push and complete. Okay, now we see multiplication, and we will also try and touch the important chapter of important part of Kramer's rule. Okay. In fact, we normally require 2 sessions for this chapter. Matrix is a huge chapter. Okay, I will do the multiplication. This you have to understand a little bit. This will be little complicated. I am taking 2 matrix. I will take matrix A, 5, 2, 3, 5, 2, 3, 1, 2, and 7. Please follow this carefully. This is not going to be so easy. So I will tell you when to relax, when to be alert. Last addition, subtraction, multiplication, you could relax, but now you have to be on your toes and you have to understand. A is this. B is 3 minus 2. I'm sorry, I'll write minus here. 3 minus 2, 5 minus 8, 9 and minus 10. Now you see the fun. The fun is multiplication of 2 matrices is only possible when the number of this particular matrix, if you see, what is the order of the matrix? You have 2 into 3, 2 rows and 3 columns. Here you see, here you have 3 rows and 2 columns, 3 by 2. In case of addition and subtraction, I told you, and I was answering many of your questions, that the order of the matrix should be same. Otherwise, addition, subtraction is not possible. But in case of multiplication, the order will be opposite of each other. In other words, the number of row in the first matrix should be equal to the number of column in the second matrix. So you see here the number of row is 2 and the number of column in the second matrix is 2. Okay. So now be very careful as we do the multiplication. This will be a little bit bigger calculation. So C is equal to A into B. We are trying to find C. Please see the step-by-step analysis. Please try to see the process in which I do. The process is this and this. That means I will first multiply 5 into 3 plus 2 into 5 plus 3 into 9. Okay, this will be the first digit which I will get. So please follow carefully. 5 into 3, 15, plus 2 into 5, 10, plus 3 into 9 is 27. This is my first number. Now I go to the second number of the matrix. This time I will take this first row and the second column. So 5 into minus 2, that is minus 10, plus 2 into minus 8, that is minus 16. So plus becomes minus 16. Plus 3 into minus 10, that is minus 30. Now I will take the second row and the first column. Second row and the first column. Second row, 1 into 3, that is 3. Plus 2 into 5, that is 10. Plus 7 into 9, that is 63. Now I will take second column and second row. So 1 into minus 2, that is minus 2. Plus 2 into minus 8, that is minus 16. Plus 7 into minus 10, that gives me minus 70. So let us now add up and see what we have got. 15 plus 10, 25. 25 plus 27 is, I think, 52. So we are getting 52 as the first number. Here we have got minus 10, minus 16, minus 30. So 30, 40, 56. Minus 56, second number. The third number, let us check, is 63 plus 10, 73 plus 3, 76. And the fourth number is minus 2 minus 16, that is minus 18, minus 70, that is minus 88. This is the product, 52 minus 56, 76 minus 88. Okay, please check. This is multiplication of two matrices. Okay, so you have multiplication of two matrices only possible when the number of columns in the first matrix is equal to the number of rows of the other matrix. So you can see that 2 by 3 and the other one is 3 by 2. Otherwise, you cannot multiply. If both are same, you cannot multiply. Right. So this is how we carry out the multiplication of matrices. Okay. Fine. Now we will go to the last part and we will take transpose we have done. Transpose we have done. Now we will take the determinant and we will do the 3 by 3 determinant. Okay. So we have taken up addition, we have done the subtraction, we have done the scalar multiplication, and we have also covered the multiplication of two matrices. So row 1 into column 1, row 1 into column 2, row 2 into column 1, and row 2 into column 2. In this way we do it. Okay, row and column wise. Okay, now we have done determinants of 2 by 2. We will try to do determinants of 3 by 3, and then the Kramer's rule. Okay, so let me take a simple example, and let me take a matrix. Let us take a matrix, say D. Matrix D is equal to 5, 10, minus 3, 6. Okay, 5, 10, minus 3, 6. What is the determinant? So determinant of D will be cross and cross. So 5 into 6, 5 into 6 minus, don't forget the minus sign, minus 10 into minus 3, 10 into minus 3. So this is 5, 6 are 30 minus of minus 30. That is 60. This is for 2 by 2. Okay. So if it is A and this is B and this is C and this is D, so the rule is AD minus BC. AD, okay, AD, left to right, minus BC, right to left. This is for 2 by 2. Now let us take a 3 by 3 matrix. This is determinant for 2 by 2. Now we move to the next one, which is 3 by 3. I am going to take a determinant, a matrix, and we will find out the determinant together. And we will see the process as well. I'm taking a matrix C, and the matrix is like this: 2, minus 1, 6, minus 3, 4, minus 5, 8, minus 7, and minus 9. We have to find the determinant. Please again be very careful in this. 2 by 2 determinant was very easy. 3 by 3 determinant a little bit tough. Of course, this is the last. You won't get 4 by 4 and above. So 3 by 3, what we do is, first, please see, we take the first number 2. So we are finding determinant of C. We take 2. Okay. Now please follow what we will do. We take 2. And then we will take the determinant of this 4 numbers, right? Which we did in the last example. So if you take the determinant of these 4 numbers, what will you get? 4 into minus 9, that is minus 36, minus 5 into minus 7. Minus 5 into minus 7 is 35. So minus 36 minus 35. First part. Now, we have to take a minus sign and consider the second digit. The second digit is -1. So which four numbers shall we consider? We will cross this one. We will consider -3, -5, 8, and -9. So we will find out the determinant of these four. So I'll write it separately. -3, -5, 8, and -9. -3, -5, 8, and -9. We will find out the determinant and put it here. -3 into -9 is 27. -8 into -5, that is -40. So don't make any mistakes in the sign part. This will be minus of -40. One mistake here and there makes the entire problem wrong. So -3 into -9 is 27, minus of -40. Okay, so the first number is taken, second number is taken, now the last number. This time it will be plus. Always remember, for the second number, we take a minus sign. For the third number, we take a plus sign. The third number is 6. So if I take 6, I will block this column. And we are left also, I block this. So I'm left with these four numbers, -3, 4, 8, and -7. So I write it separately here, -3, 4, 8, and -7. 8 and -7. What will be the determinant of this four numbers? I will write it here. -3 into -7. -3 into -7 gives you 21. -4 into 8, 32. Okay. Now we have to simplify and see what the answer comes to. First, we have 2 into -36 -35. That is 2 into -71. That is -142. Then you have minus of -1. Okay. Multiplied by 27 minus of -40. That is 27 plus 40. That is 67. Plus you have 6 into 21 minus 32. That is -11. I think so, I'm correct. 21 minus 32 minus 11. So let's simplify and see. This comes to -142. Minus of minus becomes plus. So it becomes plus 67 minus, just rub out, minus 11 into 6. That is -66. So we have -142 plus 67 minus 66. That is -141. This is the answer. You may get very similar type of problems in the exam to find out the determinant of a 3x3 matrix. Okay, so just see how we have done it. We take the first number, first row, first column, first number, 2. Block the first column and the first row, you get the remaining 4 numbers, find out the determinant, then put a minus sign, take the second number. Block the second number, okay, column and row. You are getting -3, -5, 8, and -9. Find out the determinant, plus you take the third number is 6. Again, you block this and this. So you are left with -3, 4, 8, and -7. And find out the determinant and then simplify. Okay, this is a bit, I will say, little longer and complicated. So Jayant Singla, I think you were asking, he is from Sangur, how to find determinant of 3x3 matrix. We have done it. Okay, good. Many of you, Karishma has got -141, Sneha Garg -141. Excellent. Amol Gupta. Ananya, you have got -195. Why? Please check the calculation. Somewhere I think there is some mistake in the sign, positive or negative sign. Okay. Karishma has got -141. Okay, Sharmili from Chennai. What are the changes in May 21 math study material? The changes are given in the revised study material. Please download the revised study material from ICAI.org. Basically, some corrections have been introduced and some additional problems have been introduced. Else, everything is same. Nafisa has got minus 135. I think wrong answer. The answer I'm getting is minus 141. Anchal has got 143. She's from Dehradun. Just check your calculations. See, I've done the calculation here. 2 minus 9 into 4 is minus 6. Minus 36 minus 7 into minus 5 is 35. Minus of minus 1 because we have minus 1 here. Right. So as I said that when you get questions on determinants and you get questions on Kramer's rule, be very careful with this. Okay. Fine. Let me take, we will just have time to discuss about Kramer's rule for two unknowns. Okay. For three unknowns, I think we have to keep it for the next day, even though next day we have inequalities. I'll have to do that on the next day, no other way, because we have got only one session on matrix. So I come to the last part, which is the Kramer's rule, but we will be doing Kramer's rule only for two unknowns today. And in the next session, I think I have the next class with you on 15th. On that day, I will have to take up the Kramer's rule first, and then we will go into inequalities. Okay. So we are doing the Kramer's rule for two unknowns, X and Y. This is easy. You don't have to worry. This is easy. Right. Okay, let me take an example. First, let me write the equation and then you understand. This is important for your equation chapter also, because if you are getting a question in the exam on two variables, we have discussed about elimination method, substitution method, right? You can also use Kramer's rule. Now, let me write two equations and show you how Kramer's rule works. So, A1x plus B1y equal to D1, say, and A2x plus B2y equal to D2. Say these are the two equations. Now, we have to first find out determinants, okay? So, the solution will be given by, please see, the solution will be given by x is this, y is this. We have to just find determinants. So, for x, the denominator, and for y, the denominator will be the same. What will be the denominator? It will be the determinant of these part. That means A1, B1, A2, and B2. So A1, B1, A2, and B2. Here also, for Y also, denominator is same. So A1, I'm writing A1, B1, B1, A2, B2, A2, B2. No problem here. Now, friends, for the numerator. For the numerator, what we do for x, when you have to find the value of x, you keep B1, B2 as it is. So another determinant will come. B1, B2 will be as it is because it is with y. I am concerned for x. What you have to do, just remember, very simple. Substitute A1 and A2 with D1 and D2. So just write D1 and D2 here, and the rest B1, B2 will be same. Similarly for y, A1 and A2 will be same. So I will write A1 and A2. But for this part, y, we have B1, B2. Just remove B1, B2 and put D1 and D2. So D1 and D2. This is the Kramer's rule. So I'm writing Kramer's rule. Of course, we are taking two equations. This is Kramer's rule, and very, very important for the exam, and definitely you might be getting questions on equations on in which you may have to use Kramer's rule. Sometimes Kramer's rule is easier and it provides the solution faster. So it is time for us to take one example and see whether Kramer's rule works and how fast it is in giving us a solution. So I will take two examples before we close today's session. Please remember the formula, and we will do the examples. It will make it very clear to you. Okay. So we know x and y. Please see that the denominator, both the denominator will be same. No change in the denominator. We just need to work on the numerator. So I will rub it up and take the example and solve it together with you. Fine. So let's take the example. The example is from an exam question, previous exam question. 3x plus 4y is equal to minus 14. Okay, please note 3x plus 4y equal to minus 14. The next equation is minus 2x minus 3y is equal to 11. We have to solve it. Okay. So we know the equations, we know the determinants concept. So first we write as usual x here and y here. Same process which I did in the immediately last example. Denominator, denominator. In the denominator, what I will do, I will write the coefficient of x and y as it is. So 3, I will write 3. 4, I will write 4. Minus 2, I will bring minus 2. Minus 3, I will bring minus 3. Simple. Same thing I do here. 3, 4, minus 2, minus 3. So 3, 4, minus 2, minus 3. Okay. This is called the determinant D. And the numerator is called dx. Similarly, here in y, the denominator is called d and the numerator is called dy. Now we have to find dx. What will be dx? Very simple. In place of 3 and minus 2, just include these numbers, minus 14 and 11. The coefficient of y will remain as it is. 4 and minus 3 remains as it is. So this completes your numerator part. For y, again we open a matrix. 3 and minus 2, these are with regard to x. So this will remain as it is. So 3 and minus 2 will remain as it is. But for y, the coefficient of y is 4 and minus 3. We will substitute it with 14, minus 14 and 11. So I will write minus 14 and 11. My working is complete. Now we just have to computation. So we have minus 14, 4, 11 and minus 3. In the denominator, we have 3, 4, minus 2, minus 3. Let us try to find out first the denominator. Okay, please work with me and let us solve it together. 3, 4, minus 2 and minus 3. The determinant is how much? 3 into minus 3. That is minus 9. Minus 4 into minus 2. That is minus of minus 8. So it gives you how much? It gives you minus 9. Okay, right? I hope I'm doing correctly and you are also following. So minus 9 minus of minus 8. That means minus 9 plus 8. That is minus 1. So the denominator, this one and this one, both are equal to minus 1. The denominator is coming to minus 1. Now we will find this one. Okay. So let us do the determinant here, calculation. Very simple, just cross. Okay, just a question of crossing. So we have minus 14 into minus 3, that is 42, minus 11 into 4, that is 44. So I get minus 2. So I will put minus 2 here. So that means for x, the value is minus 2 by minus 1, which is 2. X is getting the value 2. Denominator was minus 1, numerator is minus 2. So the value is 2. So we have got x equal to 2. Let us find the value for y. For y, already the denominator is obtained. We have got minus 1. Now we need to work on the numerator. So we have 11 into minus 3, that is minus 33. Minus 2 into minus 14. Minus 2 into minus 14 is 28. So this becomes minus 33 minus 28. How much? 43, 53, 63. Just check. Let me see whether this is 3. We have got 3. No, just a sec. 3. No, this is not minus 3. Yeah, it will be 3 with 3. So this is 33. Now it's fine. 3 minus 2 minus 14 and 11. 3 minus 2, 3 minus 2, minus 14, 11. Minus 14, 11. Fine. So we have 33 minus 28. 33 minus 28 is how much? It is 5. So y is having the value, y is equal to 5 divided by minus 1, which is minus 5. So the value of x is how much? 2, and y is -5. This is the process to solve linear equations with two unknowns using Kramer's rule. Okay, it's almost 4:15 now, and we will do one last problem, right? Before we wind up, we are going extra, just to make sure that you follow each and every part of this lengthy chapter, and then we will wind up for the day. So I'll take the other example and see whether we can use Kramer's rule. 5x plus 2y equal to 16. 5x plus 2y equal to 16. Fine. And we have 3x minus 5y equal to -9. So let me solve it out. So again we write x and y. X equal to y equal to. Okay, just mechanically, just do this step by step. Now in the denominator we have determinant d. Here also we have determinant d in the denominator. What will be the denominator part? 5, 2, 3 and -5. So I write 5, 2, 3 and -5. Here also 5, 2, 3 and -5. Now the numerator. What will be the numerator? We want to find x. So x, this part has to be substituted with 16 and -9. 16 and -9. Okay. The part regarding y will remain as it is. So 2 and -5 remains as it is. We are through with the x. Now we come to y. In y, what to do? X coefficient remain as it is, 5 and 3. But for the y coefficient, change it with this 16 and -9. So we will put 16 and -9. Okay. So this is what we have done, 16 and -9. So we have here, we have 16, 2, -9, -5, and 5, 2, 3, and -5. So can you just work out and see what we get? Let us try and see what we get. So we first find out this and this determinant. 5 into -5, that is -25, minus 3 into 2, that is 6. So the denominator I'm getting is -25 minus 6, that is -31. This is the denominator for both the cases, x and y. Now let us find the numerator for y. 16 into -5, that is -80, minus -9 into 2, minus of -9 into 2, that is -18. So this gives me -80 plus 18, that is -62. So the value of x is, the numerator is -62 and the denominator is -31. So it cancels by 2. X has got the value of 2. And if x has got the value of 2, you can directly find out either from here or by putting x here. In fact, if you put it here, then I think you will get y equal to 3, because 2 5s are 10. 10 plus 2y equal to 16. So 2y has to be equal to 6. Y will be equal to 3. So here x is equal to 2 and y equal to 3. Fine. So this is the process in which, dear friends, we use the Kramer's rule for finding out, the solution set to two unknowns. So friends, with that we wind up. We have covered a long journey today. I first talked about your little bit on the career part. I talked about what calculator to use, what type of newsletter. I gave the link to the CA Students Journal. And then we covered matrix, definition of matrix, the concept of matrix, types of matrix, row matrix, column matrix, scalar matrix, diagonal matrix, identity matrix, and then we went to the addition of matrices, subtraction, scalar multiplication, and multiplication. After that, we discussed and did determinants of two order, right? A, B, C, D. So determinant is AD minus BC. Then we went into the discussion of determinants using 3x3 matrix, which I did, and many of you got it correct also. Finally, we are winding up with use of Kramer's rule. We understood that Kramer's rule can be used for solving simultaneous equations in 2 unknowns as well as in 3 unknowns. Today we have taken up Kramer's rule and we learned how to use it for 2 unknowns using the simple formula which I shared with you. Finally, friends, as I said, that you see matrix algebra is used for share market, for optimum portfolio selection, for computing the return on different mutual funds, and in financial management, especially in portfolio management, matrix algebra is used to find out the risk, how much of risk every investment has, and risk and return payoff. So it's having a very important practical value, and it is used as a mathematical and financial tool, especially for investment management, portfolio management, and corporate finance. So dear friends, with that, we come to the end of today's session. I think tomorrow you have a Sunday. Please enjoy your weekend. Happy weekend. See you on Monday. On Monday, we will first discuss about the remaining part of matrices. Then we shall take up inequalities, right? So I hope you're enjoying. Hope we are in sync. You're able to follow, and we are covering each and every point together. Thanks for watching. See you on Monday.